Okay, so today's topic is relational algebra, and we are going to take one example and we will understand what are different notations and representations in relational algebra. This basically will help you out further to understand MySQL also. So it is very crucial topic. Concentrate on this one and listen to the complete lecture properly. Yes, so now see. Let us start. Okay, so here is we have one table, patient table. Um, Mostly all the requests that we are going to make that we are making from this, and already we have made hospital management system ER model. So this I'm taking the same example. Okay, so I'm taking the table of patient so that we will have some connectivity from the previous slide. Yeah. Now the thing is, we have this patient table and I want to retrieve some data. For example, I want to know, show me only the patients in ward number 3. Show me only the patients in ward number 3. That is my question. Okay. So I want to retrieve this data from there. So what will be your output manually? If you will see the patients in ward number 3 are, show me only the patients in ward number 3. So in ward number 3, only Ravi and Ahmed are there. So how to express it? So till now, we have not started SQL, correct? Algebra, we have to understand first. It will help you out in SQL. So mathematicians built algebra, which is a set of operations. Please make a note of it. It is a set of operations on tables. Every query you will ever write in database still runs on that algebra underneath. Okay. So the math behind it will come from algebra only. Hmm. So today you learn its first operation, master them, and SQL later becomes trivial. So that is the thing. And that only we are going to do. Okay. Now see how we will express this. Now you got to know what we want to retrieve. We want to retrieve those patients who are part of ward number W3. I hope you understood the question. Now let's see. And please understand this table also. We have patient ID. Patient ID is our primary key. I hope you remember these things. I'm just making you recall. Then we have other attributes, name, ward, and age. Now let's move further. Yes. So how do we express it? We have different operations in relational algebra. Okay. One idea that unlocks everything. In relational algebra, every operation takes one or two tables as input and produce a brand new table as an output. I hope you understood this. Yeah. So why does that matter so much? Let us understand it further. Because output is a table, you can feed it straight into the next operation. That is the meaning. So we will utilize these operations to find out an output and we'll feed it to the next one. And that next one to the next. And that property output is the same type as input, which is called as closure property. Which is called as closure property. Closure. Okay, I'm writing here. Closure property. Please remember this one. So basically the output is a table so that you can feed it to the next operation and then the next one. And that's how complex queries are built up. Yes. Like snapping Lego bricks together. Like that. So we'll learn these four operations today. First one is selection operation. Second one is projection. Third one is set operations, union, intersection. And then Cartesian product. Yeah. So for selection, we'll be working on rows. Selection will pick the rows. Please make a note of such things. These are very crucial and these are very confusing in exam. Projection will pick the columns. Okay. Operations will combine two tables and Cartesian product will pair every row with every other. So today we will discuss these four and in next lecture we'll discuss the joints. Yeah. Now let us see our first operation. First operation is selection. Pick the rows. Now the question is what? To represent selection, we have this representation. Okay, we will always represent selection with this representation in relational algebra. Right? It is called as sigma. Sigma. It is called as sigma. Okay. So we'll represent selection with sigma. So selection is an horizontal filter which will pick the rows. So it will pick the rows. So we wanted to know the word number. So we want to pick these two rows. Manually we can see, but how the relational algebra will represent it. Now we have to see that. If you already know SQL's where clause, that is exactly one lecture early. Uh, Like one question I asked, where this data is this, where value is 1. So in this way, I have just shown one example to you without even bothering the syntax, complete syntax of SQL. There we utilized where clause. So it works like that. This selection works like that. So how do we represent it? It has been represented like this. And how to write, if I'll write it in one line precisely, I will write it like this. Word is equals to W3 select word is equals to W3. That means the column name word and its value should be W3 from the table patient. This is our table patient. So basically the general representation of selection is like this. Sigma below condition from the table R relation. So I told you already, whenever we are utilizing the term relation, that means we are talking about a table. So that is a meaning. So when we represent it like this, so here we did the same thing. Sigma, what is W3 from the table patient. So what it will do? It will just select these two rows and it will give you the output of the table which is having only these two rows. That is your output of selection. Okay, that is the meaning. Yes. Now, see, few rows disappeared, but columns remained same. Selection will never touch the columns. Please remember this point. And condition can be anything. Equal, less than, greater than, and, or not. All these things you can utilize in this place. Yes. So we will be doing certain questions on relational algebra in my further videos, and there you will understand it more. Okay. So next one will be projection. Now it will touch the columns now. Projection. It has been represented with a Greek letter pi. So you have heard of pi. That is a representation here. We call it pi. Okay, that is a representation. Now if selection was an a horizontal filter, projection will be a vertical one. So because it will pick the columns, it will work on columns. Okay. So this is SQL's select command. So please just remember for this one, this is a select of the SQL. Select of SQL will come on it. Yes. So for right now, suppose what we want to do, we want to suppose project only the name and word from the patient table. Suppose I want to uh, select and represent only the name and word of the patient table. I want only the name and word of from the patient table. Then how will you represent it? The representation will be pi, the condition again, name and word we want because it will touch the columns from which table? From patient table. That is the meaning. So in this way you will represent it. Then what will happen? Then it will just show you name and word column from the patient table. That will happen. Okay. Now relation is a set. Okay. Relation is a set and a set by definition has no duplicates. So if projection away columns leaves you with two identical rows, projection automatically deletes the duplicates. Okay. Now suppose what will happen? Project just the word column from 100 patients and you might get back only 3 rows. Now if here in case Ravi would have been there again in 103, suppose 2 words are there, then it will just represent 2 rows. It will remove the duplicacy. of Ravi W3, Ravi W3, that is duplicated. Okay, that is the meaning of this. So projection automatically deletes the duplicates. Okay, please remember this. Projection auto remove duplicate rows. Please remember this point. Fine. Great. Now let's move to the next one. Now we want to combine these two things for one question, one query, I would say. Okay, so my first real query, let us understand this. Give me the names of patients in ward number 3. So here we want to project only the names from the table. We want to project only names. That means it should come as like this. Only names, and that too only those ones who are in ward number 3. Then Ravi Ahmed, this should be our output. Then how to represent it? First, we have to select the what? Start with this condition. Word is W3, as we have done earlier also. Okay, from which table? Patient table. So this will give us the first output. It will give us the rows. Yes, which two rows are being selected. Out of two rows, we want only names column to be projected. So project only name. Project only name. So in this way, we can run our query. So it will start with the patient, start with the whole table. It will first select the rows, only W3 patient, and then it will keep the name column only. And that is your output. Yes, selection first, projection second, filter the rows, and then trim your columns. So in this way, we are going to do so many questions on such type of queries, and you will understand it way more than this. So I hope you got some idea from this part. Now let us see the next one, that is set operations. So set operations, in this one what happens is, because tables are set, we can treat them with the classic set operations. You already know from the maths. Yeah. So union will be what? All rows in either one of the table. Intersection is what? Rows in both. And difference is what? Rows in first table but not in the second table. That we have already studied. So you can union, combine everything, either one of them. Yes, all rows in either table. Intersection, common of both. And difference will be a minus b. So I am taking two sets, a, b, a, b. So this we have studied in sets. That is the basic funda behind these three set operations. Okay, so the rule for union compatibility is that you have to remember, you can only combine two tables if they have the same number of columns and matching domains. Their domain should match. That means if you are combining any two columns, they both should be either numeric, they both should be either character. You cannot combine like this. It is having 1, 2, 3, it is having ABC. How will you combine this? Okay, so that is the thing. And they should have same number of columns. One column, one column. So then you can go ahead. But the domain should also be same. You can't union patient and doctor because they will have the different attributes. That is the meaning. So we'll see certain examples on this. Let us go further and check it out. Now, let us understand how this works. One concrete example I am taking. Here are two tables. Patient ID seen in cardiology and patient ID seen in neurology. Okay, so there are two tables: cardiology, neurology. Both are having patient ID as column. Yes, both are single column tables of patient ID, so they are union compatible. They are having only one column, and they both are numeric, so they are compatible for union. So if I will perform union on this two, how will I perform? So then I will write down simply cardiology union neurology. What will happen? It will give you this table. It will first take 101. If it will combine the common ones, 102, duplicates will be removed, 103, and then 104. That will be your output. Okay, that is C union N. Okay, fine. That will be the first output. Now let's say second one, intersection. If we will perform intersection in between these two, that means cardiology, intersection, neurology now. Then it will just pick the common ones. So it will just give you the table C union N, and it will just have one output 102. That is intersection. Then the third one, if you are performing minus. So cardio minus neuro will keep only the data of cardio, and it will delete the data which is common in both. Yes. So what it will give you? C minus N will give you what? 101. It is not a part of neuro. 102. It will not display because it is a part of neuro also. Then 103. That will be your output. I hope you got this. Yeah. So these are the very basics that you have already seen also in your previous subjects. So I hope you got some understanding of this. Now let's move further to the Cartesian product. Pair everything. Now here we want to pair up everything. So what will happen? It is a very nice funda and very interesting one. And the one that sets up everything to come. Okay. It will be utilized a lot in relational algebra. So product takes every rows of the first table and pairs it with every row of the second one. That happens in this one. So it will take every row. First, it will pair up this with this, this with this, then this with this with this. Okay. That is the meaning of Cartesian product. Representation is multiplication. So here we want to do what? This will be patient Cartesian product or with word. That is the meaning. So what will happen in this one? We are pairing up first patient table with the ward table. Yes. Then what will happen? It will first take 101 with 101 W3 with the first row of the second table, W3 15. Then 101 W3 with second row, W1 20. Then 102 W1, W3 15. Then 102 W1, W1 20. Correct. Now, why these tables are being removed? Because we have to check the ward number. We have to match it. It should be same when we are pairing up. So it is checking whether the ward number is same or not. If it is not same, like this W3 and W1, that row will be removed. And what will be your final Cartesian product? Combination of these two rows. That is our Cartesian product. I hope you got some understanding on these topics. Now, from the exam point of view, these are certain questions that can be asked in the exam. Explain the fundamental operations of relational algebra with example. Difference between selection and projection. What is union compatibility rule? Why it is required for set operations? Why does projection remove duplicate rows? Write a relational algebra expression for a given query. Please make a note of these questions. Try to answer them, drop a comment, and discuss with me. Okay. Now for you, before closing the video, a question for you. You have the schema given, employee. It is having some attributes, employee ID, name, department, and salary. You have to write a select operation for finding the employees in the sales department. First question. Projection operation for the names and salaries of all employees. Combine both of them for finding the names of employees in sales department. If projection department gives 3 rows from 10 employees, why only 3? Then perform Cartesian product and give the answer. Drop your comments with your answers. Discuss with me. And with this, let me close this video and I'll see you in next video. Thank you for subscribing my channel. Thank you to become my family. It is seriously a motivation to me to keep running this channel. Thank you, students. Bye-bye.